This exercise is related to empirical and molecular formula. As we discuss how to work out the empirical formula now, so we'll do only question related to that. And the second part about molecular that we will also do today, but later. So the phosphorite is another rock which contain magnesium compound. A sample is there which contain 2.7, because they can give you the mass or they can give you the percentage. You have to work out the empirical formula. So first thing, we have magnesium is there, which is Mg. Silicon is there, which is Si. And oxygen is there, which is O. And how much mass of each of them is given? This is 2.73 gram is there. They can give the mass, they can give the percentage. It won't make difference to the method. Now, what is our step one? What we do in step one?
We divide by atomic mass.
We divide by atomic mass. So what is the atomic mass of magnesium? You can use the periodic table, a copy of periodic table.
24.
24, good. What is the atomic mass of silicon?
28.
Silicon is 28. And what is the atomic mass of oxygen?
16.
16. So we have the atomic mass of each of them. We have magnesium, we have silicon, and we have oxygen. Now, where oxygen is 16. What we do in step two? In step two, like after solving 2.73 divided by 24, what's the answer?
0.11375.
Okay. And try to write like, because here in the second step, we don't try to round it off. So try either like example, 4 decimal places, 5 decimal places, it is fine. 4 decimal places, even it is good. So we will use here 4 decimal places. You can use mic, chat, or screen annotation if you want to complete this. So 0.1137. I'm using 4 decimal places. There is 5 as well. When you divide 1.5 divide by 28, so the answer is
0.0564.
And 3.60 divided by 16.
0.225.
So 0.225. Okay. Now, what is the step two? Step two is divide by the smallest value in the combination. Which value is the smallest in this combination? Which is the smallest value in the combination?
0.0564.
So 0.0564 is there. So we divide all of them by this value. So 0.0564, 0.0564, and 0.0564. What is this number when we divide?
2.0159.
0.1137 divided by 0.0564. It should be like a number greater than 1, as a numerator is smaller.
2.0159.
So 2.0159. So 2.01, I can say it is 2. What about 0.0564 divided by, so I'll get that as 1 because it's the same. 0.225 divided by 0.0564. What's the answer for this?
3.4 approximately equal to 4.
Can you repeat? 3.94.
Now 3.9 approximately equal to 4.
Okay, yeah. That's right. So 3.9, we can round it off to 4. This was already a whole number. So we have now an empirical formula. We have magnesium, which is 1. So when it is 1, we don't write that because it's obvious it is 1. So no need to write 1 here. Silicon, but if magnesium is 2, so we write magnesium 2, silicon 1. And what about oxygen 4? So it is Mg2, SiO4. Order is not making a difference. Like you can write oxygen first, silicon, and magnesium. But the rule of writing a chemical formula is the elements which are on the left hand side of a periodic table, like we write them in terms of period. You can see in terms of group, you can see magnesium is in group 2. So that group 2 element is first. This is a group 2 element, and silicon is the group 4 element, and oxygen is the group 6 element. So we always write the element from group 1 to group 7. Group 8 does not make like a form a compound. So you don't find it. So 1 to 7. So first is like group 1. If it is not there, then group 2, then group 3, group 4, until group 7. Is it clear, this example, how we work out the empirical formula of this compound?
Yes, sir.
Then we have this question is there, which contain magnesium is 72% and nitrogen is 28%. So we have magnesium Mg and we have nitrogen. Magnesium is there 72 and nitrogen is there 28. What will be our first step?
Divide by atomic mass.
So we'll divide both of them by relative atomic mass. So magnesium is 24 and nitrogen is 14. So when we divide 72 divided by 24, it's 3.
3.
And for magnesium, it is 2. Then what is our step 2? Step 2 is divide by the smallest value in the combination. Divide by the smallest value in the combination, that is 2. So we divide this by 2, this by 2. So this will make 1.5 and this will be 1. What is step 3? Step number 3, we like write the simplest ratio in a whole number, but we don't have 1.5 cannot be rounded off to 2. So what we do here, we just multiply them, all of them by 2. So when we multiply all of them by 2, this will be multiplied by 2, this also multiplied by 2. So this will become 1.5 into 2. So this will become 3 and this will become 2. So it means Mg, the magnesium, should be 3 and the nitrogen should be 2. That is the empirical formula of this compound. Is it clear, this example?
Yes, sir.
Okay, good.
Yes, sir.
So if they ask what is the simplest formula, what is the formula and the simplest ratio, or what is the empirical formula, all have the same meaning. You will do in the same manner. Another question in which you have to work out the empirical formula. So titanium ore contains 36.8% iron, 31.6% titanium, and remainder is oxygen, because the total percentage of all the elements should be 100. So how we will find the percentage of oxygen? So how we can work out the percentage of oxygen?
We add a percentage of iron and titanium,
Yeah,
and then subtract them from 100.
right. Because the total percentage should be 100. So we subtract the percentage of iron and percentage of titanium. So it will be 36.8 and this also 31.6. So when we subtract, we'll get the percentage of oxygen. That is 31.6 as well. So this is 31.6. Calculate the number of the moles of atom of each element. They give you the idea how to calculate the moles. That number of the moles are shown in example. How to calculate the moles, the percentage which is given, you divide by the atomic mass. So for iron, they did the first one. It was 36.8 divided by 56. Iron mass is 56. You got 0.66. For titanium, the percentage of the titanium is how much? That is 31.6. Divided by mass of titanium. What is the mass of titanium? Using a periodic table.
51.
48.
Titanium. 48 or 51? When we check the periodic table.
51 is vanadium. Titanium is 48.
Yeah. So titanium is 40. Vanadium is 51. So we will divide by 48. So 31.6 divided by 48. How many moles will get? We'll get 0.65 moles. And moles of oxygen, how many moles of oxygen are there? How to get 31.6 is a percentage. Divide by the mass of oxygen, which is 16, because we are dividing by the mass. So that will give us 1.97. So we got the moles of each. Then what is the simplest ratio of the moles? Like iron moles were 0.66, titanium moles were 0.65, and nitrogen is 1.97. So we divide by how to take a simplest mole ratio? We divide by the smallest value. So smallest value is 0.65, 0.65, and 0.65. So when we divide, what we'll get for iron, it's about 1, for titanium 1, and for oxygen, 1.97 divided by 0.67. 1.97 divided by 0.65, not 7.
2.9 approximately equal to 3.
So approximately equal to 3. So we have one iron, one titanium, and one oxygen. So what is the formula of this compound of titanium? So it contains one iron atom, it contains one titanium atom, and it contains 3 oxygen atoms. That's how we worked out the empirical formula of this, or the formula of this compound. So first we divide by atomic mass, then we just take a simplest ratio in a whole number, and we got the final answer.